Sir Isaac Newton was a 17th century English physicist and mathematician. One of the most famous of his many accomplishments was the development of his three laws of motion. Newton's three laws describe the phenomena of inertia, force equals mass times acceleration, and equal and opposite reaction. Let's take a look at each in more depth. The first law is inertia. That means that an object at rest will stay at rest unless an external force acts against it. It also means that an object in motion will stay in motion unless an external force acts against it. Theoretically, I could have cruised along for eternity had this mischievous pillow-wielding imp not shown up. But in reality, friction would have stopped me eventually. The second law is force equals mass times acceleration. That means that if an object of relatively small mass strikes another object, it will accelerate that other object less than if it had been struck by an object of greater mass. Let's review the physics. When the Garfield doll is thrown at me, its mass is so little compared to mine that the net force exerted on me is not enough to overcome my inertia, so I don't move. But when the Garfield of larger mass impacts me, the net force accelerates my mass forward. The third and final law is that every action has an equal and opposite reaction. This means that for every force enacted by something onto something else, the perpetrator of that force receives an equivalent force in its direction. As our specimen exerts force by pushing the wall, the force is not great enough to move the wall, so the force is re-exerted right back in the direction from which it came, and I move back. A prime example is the way rockets use explosions to propel themselves into the air. By exerting a massive force onto the ground, the rocket is pushed up into the sky. Thus concludes today's discussion of Newton's three laws of motion. No cats were harmed in the making of this video, but one was certainly annoyed.